In part 1 of this video series, we looked at several toolpath containment techniques that required geometry selections to contain our toolpath to a given area. In this second part, we're going to be looking at toolpaths and toolpath containment techniques that can be used to automatically identify the appropriate geometry. The advantage being is when we use these toolpaths then in templates or copy them to other jobs, they'll automatically update to the new geometry set. Let's start by looking at some toolpaths that will automatically identify the appropriate geometry. The first we'll look at is a horizontal strategy. I'll simply select it, pick a tool with a flat bottom, and apply the toolpath. We've automatically machined any flat areas on the model. The other strategy that automatically identifies its own geometry is the pencil toolpath. If I select a tool with a radius on the bottom, and again, just apply the toolpath, it's going to automatically machine any internal corners. Without going into too many details in these toolpaths, let's move on to some techniques that can be applied to virtually any 3D toolpath. In this next example, we have a parallel strategy that's cutting the top face of our part. However, when we run simulation, we'll note that the holder is gouging the part. So, how do we account for this? Well, let's again edit our operation. And on the Tool tab, we're simply going to turn on shaft and holder detection. While there are various ways we can handle a collision, we're simply going to trim the toolpath. When the toolpath is updated, it's no longer machining those areas that would result in a collision with the model. I'm going to now duplicate this toolpath and look at how we can machine the areas that we didn't get previously. I'll edit this next operation. From my library, choose a tool that has more of a reach, and from the Geometry tab, turn on Rest Machining. Again, there's various methods we can use to control rest machining, and in this case, we're going to machine any areas that were not machined in the previous operation. I'll select OK. And we now have a cutting strategy that's cutting the areas that were not machined by our previous operation. So we've contained a toolpath to only the areas where that tool and holder can fit, and we've also contained a toolpath to only those areas that have not previously been machined. I mentioned that with these automatic methods, we can copy and paste them between jobs, and they're going to parametrically update. So let's look at our next model here. I'm now going to select all 3 of the toolpaths from the previous operation, press Ctrl-C on my keyboard to copy them, and then highlight my next job, where I'll press Ctrl-V to paste them. When I regenerate these toolpaths, you'll see that they're automatically updating to my new model. The same would be true if we were to select these toolpaths and store them as a template. Okay, let's move on to our next example. Here, we have a contouring operation that's machining the entire model. However, the contouring operation is most appropriate for steep walls. So we're going to look at how we can confine the toolpath to only those steep walls. I'll edit the toolpath, and on the Geometry tab, activate the slope confinement. I can then confine my toolpath to only those walls that are between 60 and 90 degrees. When I select OK, the toolpath is updated to just machine the steep walls. We could couple this together with another operation that's more appropriate for our shallow faces and combine them into a template if you'd like. I should briefly pause for a moment too and give you one more trick. So let's duplicate another copy of this contouring operation, and in this copy I'm going to show you a neat little trick similar to the Machine Steep Areas option on the Parallel toolpath. On the Passes tab of the Contour toolpath, we've got an option to machine shallow areas. Much like Machine Steep Areas, we can adjust the step down and step over to be finer in these shallow areas. So we'll just go ahead and select OK. And now we can see the density of the toolpath in the shallow areas is tighter than on the steep areas to maintain a similar surface finish across the entire part. Let's now move on to our final toolpath containment technique. This technique is considerably valuable to mold makers. Here we have a toolpath that's rolling over the sharp corner of the model. This is undesirable in molds where we want to maintain a crisp edge. To stop the tool from rolling over the edge, we're going to use the Contact Point Boundary option. Moving to the Geometry tab, I'll simply check Contact Point Boundary and select OK. Now we can see at the top edge of the model, we're no longer rolling over the edge. Instead, we're simply contacting the point boundary with the edge of the tool. Well, with that, we've reviewed several techniques for containing 3D toolpaths in HSMWorks. You should now be able to use both techniques that require geometry selection as well as techniques that can be automatically applied to toolpath templates or copied between jobs. I hope you found this video series to be a help.